I want to introduce you to my cat Riley. He is underneath the plant lights, trying to grow bigger than he already is. Good morning. Today we're going to make a major change in what we're looking at. We have been looking at how moving charges would create a magnetic field. Today we're going to reverse all that. We're going to try to use magnetism to make the charges move. So instead of the moving charges making magnetism, we're going to have magnetism move the charges. We all remember, hopefully, that if I have a charge in a magnetic field and the charge is at rest, it will just sit still. Hopefully we remember that if the charge is moving, it will feel a force. What we'd like to try and do today is get that charge that is not moving and not attracted to these magnets to somehow move using the magnet. At first glance, it seems impossible. Well, let's recall that when we have a moving set of charges, they will create our magnetic field. We see this around our wire, and we saw that the magnetic field circled around the wire either clockwise or counterclockwise. We also saw that we can make a rail gun, where we could run electricity through this rod using a battery, and this rod would be pushed along the rails. We saw it in real life. Not really, I wish, but a real life version of this. We see the rod being forced across the rails. So what we're going to try and do today is we're not going to have a battery. We're just going to have our rod like this, and we're going to push the rod through a magnetic field. And when we think about this, when we're pushing this rod through the magnetic field, that this rod contains electrons. They're part of the structure of this metal. With metals, those electrons can move around easily. So if we push this through the magnetic field, we now have moving charges going through a magnetic field. They're moving because the entire rod is moving. These moving charges are going to feel a force. And if we use our left-hand rule, we're going to have our fingers in the negative Z direction, our thumb in the X direction, and the charges will be pushed in the positive Y direction. They will head to the top of this bar. Left behind will be positives. It'll look something like this. So again, as I'm pushing this rod through the magnetic field, the charges on the rod are moving because the rod is moving. They are in a magnetic field, so they feel a force, and they're going to try to move in the positive Y direction. They'll move as far as they possibly can, and they will congregate at the top of the metal rod. The positives are left behind. Remember, the positives didn't actually move. Here's the thing. If we attach wires to this rod and we put a light on those wires, we will now see that the electrons will flow through the wire, through the light, and back to the other side, neutralizing these positives. And in the process, the light will come on. We have been able to create a current without using a battery, without using chemical reactions. We did it using simply a magnetic field. The neat part is once the electrons get back here and neutralize these positives, if the rod continues to move, those electrons will once again be forced to the top, and this process will continue. So long as we're moving this rod through the magnetic field, the light will be on. The flow again goes from negative to positives as the electrons repel each other and are attracted to the positive side. However, be aware that if the light is also in the magnetic field, when I push this whole system together as one unit through the magnetic field, the light won't come on. The reason it won't come on is because now the electrons in this wire are also forced toward the top, and they will prevent these electrons from actually flowing. So in order to get it to work, only part of the circuit will be in the magnetic field. We're going to do a little experiment today. This is your main job for today, where we're going to take a rod and we're going to push it along a set of rails in a magnetic field. The light bulb wire will not be moving, only this one wire will be moving. We will change a bunch of different parameters, and your job is to figure out how each parameter affects the amount of electricity flowing through the circuit. So anyway, that's your goal for today. The directions and lab sheet will be posted online. Make sure you share your results with me. And please be very specific when you show me your graphs and explain your graphs. Make sure you use sentences like, when we double some variable, what happens to the other? Okay, don't be vague, be very specific with your concluding sentences. Anyway, guys, good luck. Hope to see you soon. Take care.